Did you know the Swiss rebuilding, nicknamed the Gherkin, in London, was designed to significantly reduce wind drag by learning from ocean sponges? You're listening to Wild Engineers, decoding nature's intelligent designs in your coffee break. Let's dive in. In mechanical engineering, air is something we're usually forced to move when we want to in the context of buildings. But in nature, of course, air moves without motors by harnessing optimised form, temperature and pressure. Hi, I'm Melanie Farmer, and today's question is, how does nature move air passively? In the deep ocean lives a glass sponge called the Venus flower basket, Euplectella aspergillum. This glass sponge has no lungs, muscles or moving parts. However, through some clever geometry evolved over millions of years, it can draw fresh oxygenated water through its body continuously and effortlessly, expelling waste-laden water out. Clever sponge. Let's understand this mechanism. Okay. So it has a lattice-like silica structure, creating varying pressures when currents pass across it. Of course, the ocean is dynamic, and small changes in flow generates internal circulation. A little low pressure here and slightly higher pressure there enables and encourages fluids to move because they have somewhere easier to go. The mechanism relies on curved, tapered forms, accelerating flow in some regions and slowing it in others. Temperature differences because of the varying density of the sponge material. And so put simply, hot air rises. And rather than one big donut, there are many small apertures, like a spider's web, reducing turbulence and energy loss, dissipating that pressure. Flow is channeled around small spirals with no dead ends or direction changes required, and the result is stable ventilation, a great example of using low-energy processes to achieve an outcome. 30 St Mary Axe in London, also known as the Swiss rebuilding or Gherkin to some, as it is shaped a little like the vegetable of the same name, applies this biological insight at an urban scale. The Swiss rebuilding is shaped the way it is for more than aesthetics. The building uses a spiralling atrium system. Air enters through perimeter openings, warmer air rises naturally, and pathways are designed to spiral air under pressure up and be exhausted out of the building. The curved facade reduces wind stagnation and creates alternating zones of positive and negative pressure. In mild conditions, this significantly reduces reliance on mechanical ventilation because the building form does the work naturally. We started by asking, how does nature move air passively? Nature's strategy, inspired by our glass sponge, is to work with natural forces by shaping pressure where it wants it. The core mechanisms are geometry-driven pressure differences, pressure release spread across many small lattices, and continuous low-resistance flow paths, all allowing wind and temperature forces to travel seamlessly in and around the structure. So, when mechanical systems feel oversized, overworked, and somewhat unwieldy, what if we could find something in nature with a more elegant solution so air moves itself? That's wild engineering. Thanks for listening. Stay wild and see you next time. That's it for this episode of Wild Engineers. If you're inspired to apply nature's intelligence in your own work, check the show notes for more detail. If you know someone who could benefit from this episode, please share and help us redesign our world inspired by nature.